All right, so we are getting ready for Chapter 8. Getting ready for Chapter 8 is graphing parabolas. So the first thing we need to do is review the factoring that we did in Chapter 7. So let's go through the goal. Students will connect their knowledge of solving quadratics to a visual representation of a quadratic graph, a parabola. So a quadratic equation is going to be this. ax squared plus bx plus c. And those are the things that we factored. Those are the equations that we factored just in like November and December. So an x-intercept is where the parabola crosses the x-axis. Okay. My zeros are the same as the x-intercepts. The solutions to my quadratic equation. The solutions to my quadratic equation. My solutions, my roots, it's all the same thing. These are all synonyms. X equals something and x equals something. That's what we're going to get. The x values. So all of these words that I use all mean the same thing. An x-intercept, that's the actual dot that my parabola is going to hit the x-axis. The x-axis is the horizontal line. A zero in the solution and the roots, these are all the same word. So let's factor and solve and find these zeros. X squared plus x minus 12. What are two numbers that multiply to make 12 and add to 1? Because this is like a 1, right? X squared plus 1x minus 12. Okay. 3 and 4, 6 and 2. Hold on. 3 times 4, 6 times 2, 12 times 1. Well, they're multiplying to make 12. These all do. But which one adds up to a 1? We take the 3 and 4 first, because we know that those are close together. So in your parentheses, put a 3 and a 4. X and X go in front. 3 and 4. And new volunteers always. I don't want the same people all period. I want a positive 1. So a negative 3 and a positive 4. Because remember, outside, inside have to add up. So now set your parentheses equal to 0. X minus 3 equals 0. X plus 4 equals 0. So I just rewrote my parentheses in this line below. X minus 3 equals 0. X plus 4 equals 0. And then I have to solve for x. Solve for x. X equals what? X equals positive 3. Because, X minus 3 equals 0 means you add 3 to both sides. And then x plus 4 equals 0 means I subtract 4 to both sides. So, negative 4. So I'm going to write that 3 and negative 4 are called the zeros, solutions, x-intercepts, roots of a quadratic. And I'm going to pull up Desmos for you. Sorry. If in Desmos I graph x squared plus x plus x minus 12, and in Desmos I don't need to put the equal 0, but look at where it hits. Positive 3 and negative 4. And it's a parabola, and this parabola goes forever in both directions. Up, 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 up. This corner point where it makes the turn is called the vertex. All right, let's go to the next one. Number 2. Factor and solve. Okay. This is where, now I've used the box method before, but I want to talk to you about something that we did before break when I had factoring. If my parabola starts out with 3x squared, I know it has to be a 3x and an x. It has to be. That's the only way to make 3x squared. Now, I have to multiply to make 8. So I have to think of the numbers that make 8. The numbers that make 8 go in my last section right here. Okay, please don't answer every question. You understand? Thank you. It could be 8 times 1. It could be 4 times 2. I'm going to have to play around with this a little bit because of that 3. I want the outside inside to add up to negative 2. So it could be 2 times 4 or 4 times 2. I don't know. So I put those 2's and 4's there to practice. So I'm going to start out by doing the outside inside of the top number, the 2 and the 4. So the outside inside of the top number is going to be 3 times 4 is 12. That's outside. 12x and 2x. The 12x and 2x make 2. 12 and 2. 12 and 2 don't make 2. So it's not going to be this 2 and this 4. So I'm going to erase this 2 and this 4 because I know that's not it. Now, outside, inside. 6x and 4x. Does 6x and 4x have a possibility to make 2? 6 and 4, can they make 2 when I add them? They can. So I'm going to say, okay, that's going to be it. The 4 is going to be here. I'll make it bigger. All right. And how am I going to make a negative 2? A 6 and a 4, outside, inside. Which one should be negative and which one should be positive? Negative 4 and positive 6 makes positive 2. Someone else. Negative 6 and positive 4? You're right. The negative 6 goes with the 3 and the 2. That means that this 2 is negative right there. And the positive 4 would be this here. Okay. So those are my two parentheses. 3x plus 4, put it in here. 3x plus 4, x minus 2. Now I have to set those equal to 0 and solve for x. So these are still all equal 0. 3x plus 4 equals 0. X minus 2 equals 0. So I'm factoring from last semester, and then I'm setting the parentheses equal to 0. All right, 3x plus 4 equals 0. Solve that one first. What do I do first to get x alone? What do I do first to get x alone? Or no, what do I do first to move? To like isolate my variable? Should I move the 4 first or should I move the 3 first? No one remembers? Solving equations, two-step equations. You're going to move this 4 over to the right side. Minus 4. 3x equals negative 4. Then what? How do I get x alone? Divide by 3. X equals, I'm like out of space, negative 4/3. That's not a number that I could plot. That's not like, that's an improper fraction. 4/3? I need to change that to a mixed number. So it's like, how many times does 3 go into 4? So 3 goes into 4, it's 1 1/3. Negative 1 1/3. This is how I did it. I went like that. How many times does 3 go into 4? I divided. Okay? All right. X equals negative 1 1/3. 3x plus 4 equals 0. Negative 1 1/3. And then x minus 2 equals 0. Add 2. That one's easy. X equals 2. Negative 1 1/3 and 2 are the zeros, solutions, x-intercepts, roots of the quadratic. So this, I just did a lot right there. I did elementary school stuff where I changed an improper fraction to a mixed number. So everything in math you just can't forget every year. And every teacher's told this to you. It all builds on itself. So you need to know how to solve an equation from Foundations 1. You need to know how to change an improper fraction to a mixed number from elementary school. And if I'll refresh your brain. So those are going to be where it crosses, and let me show you on Desmos. (3x squared) minus 2x plus or minus 8. So look at how negative 1 1/3. Negative 1 1/3 is my x-intercept, and 2 is my x-intercept. So what we're going to do today is you guys are actually going to plot these points for homework. Now you won't know You won't know where this vertex is, so you'll just do an approximate curve. What I care about is the x-intercepts. But you won't know how low or high to go. We haven't learned that yet. We're just starting with the basics first. We're going to plot the x-intercepts on a graph, and then approximately make a curve. Let's do number 3. Okay. X squared plus 10x plus 25. Two numbers that multiply to make 25 and add to 10. 5 and 5. You're right. So x plus 5, x plus 5. That's super small. Sorry it's so small. X plus 5 equals 0. X plus 5 equals 0. Solve for x. They're two of the same thing in a row. So what is it, guys? Negative 5. You subtract 5 from both sides. X equals negative 5. Negative 5 is called the zero, or the solution, or the x-intercept, or the root of the quadratic. There's only one answer, which means the parabola only has one x-intercept, one root, one zero, or one solution. If I graphed it, it would be at negative 5. 1, 2, 3, 4, 5. It would be at negative 5. So draw a little graph, because this is what you're going to have to do for your homework. And the parabola, draw a parabola that hits it and bounces off of it like that. The last example. Okay. So, obviously 7x has to be 7x and x. Has to. That makes 7x squared. Sir? 3. Well, the last numbers are 3. Well, it has to be 1 times 3. But is it like 1 times 3 or 3 times 1? I'm not sure. So, 1 and 3 or 3 and 1? I don't know. I need to make 10. Outside, inside needs to make 10. Let's do the top numbers first. Outside, 7x times 3, 21. No way. Inside, 1. Did 21 and 1 make 10? That's huge. That's way too big. It's not going to be 21 and 1. See, outside, inside, first, outside, inside, last. 7x times 3, 21. 1 times x, 1. Nope. So let's try 3 and 1. 7x and 3x. That could make negative 10. What should the signs be if I want it to be negative 10? Both negatives. Yeah, that would make negative 10. So you put the negatives inside. Equals 0. Set your parentheses equal to 0. 7x minus 3 equals 0. X minus 1 equals 0. and solve. So you add 3 to both sides. 7x equals 3. Divide by 7. X equals 3/7. 3/7 isn't even to 1. That's like really small. Next, add 1. So I'm going to plot my points at my x-intercepts, my zeros, my roots. 3/7, which is not even to 1 yet. 3/7 would be like right here, plotted on the graph. It's a little after 1. 3/7 is a very small fraction. Make it big because I'm using a pencil on black lines. And then x equals +1. This parabola is going to have x-intercepts really close together. Your job is to draw a parabola. I don't care how low or high or how low it goes. You're just making it look like this. Something like that. It has to cross through those twice, and it's a U-shaped. All right, I'm answering the last questions. How can you find the x-intercepts of a quadratic function? You factor and solve for x. How are the x-intercepts, the zeros, and solutions, the roots of a quadratic equation related? They're the same. So let's look at one that's going to be kind of for homework. Your homework is going to be the next pages. You're going to have to factor all these. Look at this list. I gave you easy ones. I didn't even give you any number in the front, an A. You know what A would be like 2x squared or 3x squared. So your job is going to be, I think that you have 2 options. The graphs are on the next page. Do you want to factor them on this page, or do you want to factor them on the actual graph? It's completely up to you. Because if you turn the page, you'll see I wrote it again. So you decide. If you really want to do, like, you guys, can we do number 4 together? This is called the difference of squares. This is a special. It only has 2 terms. What 2 numbers make 49? It's a perfect square. So x7, x7. What should my signs be to get a negative 49? Difference of squares is what I remember. Difference, the word? Positive and negative. So that means that if I set each parenthesis equal to 0, x plus 7 equals 0, I solve it, I get that x equals negative 7. X minus 7 equals 0, I solve it, I get x equals positive 7. That means that I'm going to go to the next page, to number 4, and I'm going to say that x equals 7 and x equals negative 7. And then you're like, oh, Mrs. Grant, the graph is a little bit smaller. That's okay, just count. Pretend where it would be. At 7 and at negative 7. On my x-axis. 1, 2, 3, 4, 5, 6, 7. Like approximately there. and then x equals negative 7. 1, 2, 3, 4, 5, 6, 7, approximately there. And I have to draw a super wide U shape because it has to hit both. Like, check this out. Oh my gosh. Something like that. So your job is to factor it, find my x's, zeros, roots, solutions, x-intercepts, plot those x-intercepts, and draw just any old curvy shape through them. Parabola. Number 3 and number 5 are also kind of special because they're difference of squares. What two numbers make 1, you guys? What times what makes 1? 1. This is again a difference of squares. X plus 1, x minus 1. My two solutions are x equals negative 1 and x equals positive 1. So you're either factoring by using a technique like difference of squares, if there's 2, or you actually make the 2 parentheses and you play around with the numbers. So 1 through 12 is your homework. Let me stop the recording.